Welcome back. We're going to go ahead and continue our discussion and look at significant figures. So my first topic I want to go over is accuracy versus precision. And I think the best way to understand this is not through these formal definitions. Whoops, spelled how wrong. But through this image. This is the image that really made a lot of sense to me when I was going through college at Fresno State. So what we have here is showing you the difference between accuracy and precision. Okay, so if we are looking at a bullseye, okay, and we have thrown our darts or whatever it may be, let's say we're throwing darts and we hit all of them on the bullseye. Okay, that means that our throwing is not only accurate, but also precise. Okay, but say that I am trying to hit a target, or trying to hit the bullseye, I instead am over here. Okay, it's not accurate anymore because it's not right on the dot, but since they're all clumped together, it is precise. Okay. Now if I'm, again, trying to throw my darts and I have them all around the target, they're pretty accurate, but not precise. They're not clumped up in this little tiny area. Okay, so this is accurate, but not precise. Now if we have, they are spread out and they're kind of off to the side, they're not anywhere near the bullseye, this is not accurate or precise. Okay, so I just wanted to give you a little bit of idea when we're looking at data, any kind of measurements, accuracy versus precision. Okay. Now I need to go over what's called significant figures. Okay, and we call that sig figs for short. Okay. These are figures that are significant to our I guess data or measurements. Okay, so I will also have a supplemental video that may describe it a little bit better than I am, but I will try my best. Okay, so say I have, let's see, trying to think of something. Say I am measuring a distance, okay, and I say that it is 2.4 centimeters. Okay, say I'm using a ruler. Okay, we know that rulers, if I can draw one quickly, okay, have these little marks on them. Oops. And say that these are the centimeter marks. Okay, say that these are centimeters. And between each of these lines usually are millimeters. Okay, I can't draw that many in there, but hopefully you guys know what I'm talking about. See, maybe I can draw it on a larger scale. So there'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, right? Because there's 10 millimeters in 1 centimeter. Okay, and if I say something is 2.4, okay, 2.4 centimeters, say I'm looking right here. Okay, I'm saying that this is 2.4 centimeters. I can only get so accurate when I'm measuring, okay, because it could be, let me get another color here. I could be looking at it and it's very, very close to that line, but it might actually be like right here. So if I put that little dot, so whatever I'm measuring might actually be just a tiny bit over that line. Okay, but since I'm using this specific ruler, I can only go to this number of digits of significant figures. Okay, so that's my little explanation of significant figures. Again, I think that other video will be maybe a little more helpful, okay? But when we're looking at significant figures, I'm not going to be super picky with it, Okay, I know in other classes they might be. I remember when I was taking chemistry course, they were really sticklers for significant figures. But as long as you are in the right area, I'm not going to, take a bunch of points off or something. It's not a huge deal, but I want you guys to understand that it is something that is out there. Okay. Another thing is with significant figures, you need to pay attention to when you're multiplying or dividing or adding and subtracting. Okay, so say I want to add 4.573, centimeters to this. For some reason in my calculation, this is what I need to do. Okay, and so when you're adding it, you're like, okay, well that's a 3, 7, 9, 6 centimeters, right? Okay, but the problem here is for this first value I only have 2 significant figures. So what I'll need to do is say, okay, well these last 2 numbers, they don't really matter to us, so we can just toss them. Okay, but you may want to pay attention to the rounding situation. So I would probably take 6.9, or I would take 7.0, since this is a 7, I would round up. Okay, but again, it's kind of up to you. Both of these are fine for me. Okay, another thing is if you are multiplying, so if you have 2.4 times, 1.13, okay, and you put it in your calculator, so let's see, because I can't do that in my head really fast. And I get 2.712. Okay, fine and dandy. But again, I only have these 2 significant figures here. Whoops. Okay, so I would just say, these are my 2 significant figures, throw the rest out. So my answer would be 2.7. Okay, so notice they're a little bit different in the way that they work, but they're still pretty similar. Okay, so again, I think that video is going to be super helpful. Made a lot of sense to me when I went through it, but this is the basic idea of the significant figures. Okay, so let's move on to some physical quantities. Okay, so we have 2 types of physical quantities that we look at, and that is going to be scalars and vectors. So scalars are things that we tend to talk about typically. So they just have a magnitude. Okay, so mass is one, temperature, speed, distance is one. Okay, anything that has a magnitude. Okay, vectors on the other hand have magnitude and direction. So not only will it be, say, 27, it's going to also have some kind of direction. So 27 what, let's say, meters east. Okay, this is a this is a vector. Okay, it has a magnitude and a direction. Okay, so things that have, things that are vectors are displacement. So something like what I just wrote, that's a displacement. Velocity and force. Okay, and we'll talk about a few more down the road, but I just wanted to get you guys in that mindset of what a scalar is versus what a vector is. Okay, typically scalars, just you indicate them as a letter. So mass is just m. Okay, speed is just a v. Okay, but when we look at vectors, we will put a little bar or an arrow above them. Okay, so for velocity, that is v bar, or you can say v arrow. So sometimes you'll see it like that. Sometimes you'll see it like that. Let me draw that better. Okay, sometimes it'll be bolded. Okay, so sometimes in different textbooks, you'll see them a little differently. I believe our textbook uses something like this or this. You'll probably see me write bars a lot, but it all means the same thing. They're just trying to indicate that it is a vector. Okay. Now we have this illustration here just to kind of show you the idea of vectors. So if I'm traveling from point A to point B, okay, my vector from A to B is going to be a straight path, and it has a magnitude and a direction. Okay, so say that this is, I don't know, 10 meters. Okay, and then we need to know the direction. So in looking at this compass here, it would be northeast, right? It looks like it's going in that direction. So northeast. Okay, and we can even put a value as to the exact angle at which it's traveling, or we're traveling, but we'll get into that in another video later on. Okay? All right, so again, talking about vectors, we'll see it in velocity, acceleration, displacement, and different forces. Okay, so if I'm driving a car and I have a positive velocity, okay, we know which direction our car is traveling. Okay. Now, if we have an acceleration and we have a positive or negative, it'll tell us whether the vehicle is speeding up or slowing down. Okay. One question I wanted to pose to you is, how can we change the acceleration of this car? Okay, just in general, how can we change the acceleration of a vehicle? How can we speed up or slow down? Okay, that would be using the gas or the brake, right? So it's thinking about these everyday scenarios and putting them to good use, okay? We also have displacement and forces, okay? And the forces is really going to be just dependent on the direction of the forces. So say I am pushing a box, say I'm moving and I'm pushing a box this way, that's also going to be the direction of my force. Okay? All right, so that's a real quick lowdown on a little bit of the idea. Again, next week we'll be going into further detail of all these things, so I wouldn't worry too much, just getting the basic concept here. Okay? Now, we need to go into more talk about vectors, and you're going to be very tired of hearing about vectors by the end of this video, I'm sure, or the series of videos actually. Okay, there are a few ideas that I need to kind of plant inside of your guys' brains. Okay, so when we're looking at two vectors and they are in the same direction, so we have A here and B, they're traveling in the same direction. Okay, this means that they are parallel to each other. Okay, so A is parallel to B since they're traveling in the same direction. Okay, or not traveling, they're pointing in the same direction. Okay, now we can do the exact opposite of that and say that A is anti-parallel to B. Okay, so they're pointing in the exact opposite directions now. Okay, now if I have a vector A and a vector negative A, this means that they're the same exact vector, but now they're pointing in the opposite direction. Okay, and so again, they are anti-parallel. Okay, so A is anti-parallel to negative A. So that negative here tells you the direction of the vector. Okay? All right. If we have two vectors, A and B, that are going the same way, so same direction, and are equal, so same direction and magnitude, I should say, this means that they are equal. Okay,